Assalamualaikum and hi. We are from ECV 3213 from the group 2, and today we are going to discuss about our structure project. This is our meeting number and group member name.
Okay, Assalamualaikum. My name is Anissa Muhammad Jalin. My metric number is 187888. Okay, as for in this video, I will do the introduction part for this project. Okay. As you know, the structural analysis is the computation of information, internal forces and stresses, structural performance of the engineering design, and also one part of the structural performance of the engineering design, and ensure the soundness of structural integrity in design without dependence on direct testing. Okay, as for this project, we are giving a client proposed that a commercial center comprising of a 6-story building, approximately 40 meter long times 80 meter wide, is required to a city suburb. Okay, from the diagram, you can see the details of the building that being proposed by the client. Okay, so next, basically in this project, we need to discuss the consequences of the modeling approach with our assumptions and suggest an extensive analysis of the building under various viewport provision and load combination with several subframe analysis. Okay, from this project, the loading, the left load proposed is for the ground and the first floor is 10 km per meter square. For the second floor is 0.6 km per meter square, and as for the roof is 0.3 km per meter square. For the dead load, we calculate the survey and the finishes. We assume that 0.76 km per meter square, and the material for the SU is 40 meter per millimeter square, and the reinforcement is 460 meter per millimeter square. Okay, for the column, we assume that we use the size of 300 mm times 500 mm. Okay, so the problem statement of this project is that we come with the 5 problem statement as for this project. First, what method to be used to analyze the 6-story building structures. Second, what the consequences of the modeling approach or assumption. Third, what are the differences between the manual analysis method, two-dimensional and also the manual analysis, and also the 2D dimensional based on the result obtained. The fourth one is which method is the most suitable way to analyze the building structure, and last one is what type of assumption can be made in order to get the optimal result. As for the assumption are made in order to ease the process of the project since certain parameters and some factors that can affect the behavior of the structure. Okay, assumption that we did in our project is that we assume the maximum distribution rate of the BSW. So the rate one is one way slide, while the green one is a 2-way. So the rate one is W and the green one is full W. Okay. And we also assume that frame is symmetry and analysis will be made for one segment. Next, the assumption is assume value of the value of modulus of electricity is 2.0 as 0.8 kilopascal. FCU is 40 N per millimeter square, and FYF 600 N per millimeter square is using Polypro and also the SAP 2000. As for the SAP 2000, the dimension of the column and beam has been neglected since we are more focusing on the bending moment and shear of the structure. Okay. Besides, assumption that we made, that assumption that we use in this, be made in terms of condition, can also be made in terms of condition or environment of the structure itself, so that the structure will be built in more stable.
Assalamualaikum and a very good morning. My name is Muhammad Al-Faiz. My matric number 195879. I'm also from Group 2. So I will explain more about the methodology that we use for our project. The first one is we do all the specification process, and there is the thing that we got from the question. The first one is about the QK and GK, and we must change the P with our team number, there is 2, and we got the first floor is 1, second floor is 0.6, and the roof is 0.1, and our GK is 0.76, and then we show all the dimension that we get about the slab, beam and column, and then we calculate the uniform distributed load to know the type of slab is one-way slab or two-way slab, and then we choose the code that we want to use for this project, and our team use the code from Eurocode 2, and the value of n can be calculated by using the formula n equal to 1.35 GK plus 1.5 QK, and you also can use British Standard by using a formula n equal to 1.5 GK plus 1.6 QK, but you will get the different value of n and different value of load. And then after that, but now don't forget to calculate the moment of inertia also. And then you can use the one level subframe for your structure, and actually there's three method you can use. The first one is one level subframe, and then joint method, and the last one, if I'm not mistaken, the continuous one. Such as the picture is show the one level of subframe, and the third one, after you get all the stiffness, the distribution factor, and the fixed end moment, you can calculate the shear moment and reaction by using moment distribution method. You also can use slope deflection method, but it is up to you, the thing that the method that you want, but I choose moment distribution method. And then I will get all the reaction, moment and the shear for my structure. And then to compare my answer, I can use the first one is Limpro software, that is more to 2D, and just as the picture. And the second one, I also use SAP 2000, but this SAP 2000 is more to the 3D structure. It's more complicated to use other than Limpro, such as the picture one. Okay, the first one is specification process, the second one is one level subframe, and the third one is moment distribution method, the fourth one is Limpro, and the fifth one is SAP 2000. For the comparison, I use the moment to compare the value that I got, other than use the shear and reaction, but we also can use two of that, but I prefer to choose a moment. And from, as you can see at my table, there are only 4 members from the structure that have same value of 0 moment, even we use the different method. There is Limpro software and manual calculation, it also have the value of 0. And you also can see at member DA and GA, there are only 0.005 kilonewton meter value of moment that have difference between these two members. 0.05 is quite low, I think. So I think this error maybe occurred due to the human error that I make during the manual calculation process. Maybe I did not round off the decimal place is the same way, so I got the different value, but it's not too high. And let's see the percentage error. Percentage error is actually the comparison between the value that is derived from the experiment with exact or true value. However, in our project, the values from the Limpro software analysis was assumed as actual value, while the value from the manual calculation through moment distribution method, I assume it as estimate value, and I will get the formula is manual calculation value minus software analysis value divided by software analysis value and times it by 100, and you will get the percentage error. From the table above, as you can see from the table, the error actually occurred due to the different value of modulus elasticity and moment of inertia that we have been set up used in the Limpro software and manual calculation. For the manual calculation, actually I calculate the moment of inertia, but after I simplify the formula, I can cancel it. I can cancel the moment of inertia. But for the Limpro software, the value of moment inertia and elastic modulus, I set it up to default. So there is difference between E and I, but the value is not quite different. So I can say that my manual calculation is correct, and maybe I achieve the objective for our team. That is, we can show the difference between using manual calculation and software. And that's all from me. Thank you.
Hello everyone, my name is Angelina Gi Anajari. My metric number is 196028. So today I'm going to present about the results of our reports which are for ground and first floor. So this is the content of my presentations where I'm going to present about the briefing about the manual calculations and then Limpro analysis, and lastly is percentage errors. So the first one is manual calculations. In manual calculation, we are using moment distribution method to analyze our multi-story frames. So in here, we could see that the code of British that we are using is Eurocode 2 and British Standard. But in overall, we are using Eurocode 2. So as you can see here, the value of that load, which is GK, is equals in Eurocode 2 is much lower than in British standards. This clearly shows that by using Eurocode 2, it could save more money and it also save time. But then in British standard, its dead load is 1.4, which this is a little bit higher than Eurocode 2, but in British standard, it's more safer, but then it's also more costly. So here also we could see that our united distributed load is one-way slab because our length is our height is much longer than our width. Okay, so next, so this one is for the overall of the buildings, the Eurocode 2 and the British standard. So here we could see that the value of n in Eurocode 2 is much lower than British standard. As I mentioned before, Eurocode 2 is more economical because it's more economical because it its death load is only 1.35, which is a little bit lower than British standard. And then we analyze, we do calculations and we analyze our these multi-story buildings by using some moment distribution methods. Where this moment distribution method, as we know, it is very suitable and very easy to be used to analyze statically indeterminate beam and rigid frames, because the joints of these structures all joints to be analyzed is all are fixed. So we could calculate the fixed end moments, and then In here, in fixed end moments, uh, the the this time in fixed in moment, the equilibrium is not achieved, and then we have to achieve it, we have to distribute it, and then we do it iteratively, and we get the total moment until it achieve. When in total moment it's already achieved the equilibrium, where if we can see here all the distribution is zero, this means that it already achieved its equilibriums. So over here we this is direction, the calculations of directions for the first and ground and first flow. So next is LinPro. Here is the results of our LinPro analyzing. So here we're assuming that our modulus elasticity is to be the same as the LinPro's default. So yeah, here we could see that we're going to compare these results, these LinPro results, with the manual calculation result after this. So next is percentage errors. So in percentage errors, we could see this here. This is what I said before, that manual calculations, the comparison between the manual calculation and the LinPro software. So as you can see here, that manual calculations is a little bit different with the LinPro software. So this might be due to the as you can see here, it's very obvious that in manual calculations we are using 3 decimal places, while in the LinPro software it analyzes it by 2 decimal places. So it might have a little bit of errors in there. So all the errors is less than 0.2. This shows that our objective is achieved, where our manual calculations, which we are already verified with LinPro software, is correct and almost the same.
Okay, this is the methodology for the manual calculation. First of all, by using the formula below, we need to find the permanent and the moving load. Second, we need to find the value of the load case, which is N, and the distribution load W, by using the formula given. Third, we need to determine whether the load distribution is one-way slack or two-way slack by using the equation below. Next, we need to find the value of moment of inertia, which is I equal to BH square over 12, the stiffness K equal to I over L, and the distribution load dF, which is K over total K. K is the stiffness, and the total K is the total stiffness at the support. By using the moment distribution method, which is MDM, we can find the moment each of the longitudinal member, and after we find the moment distribution method, we can find the reaction each of the support, and we can compare it with LinPro and the SAP 2000.
Okay. Okay, next I will present about the output of the SAP 2000 that we use for the 3D modeling analysis. Okay, the first one is the 3D modeling for frames. The first one that we use, where the load and the assumption we put in the frame. Okay, the second one is the output after we run the analysis, which is the deflected shape of the frame. You can see here the green one, the green for the second picture, the green is the deflected shape, while the grey is the actual frame. Okay, next. Okay, here we can see the shear force of the frame in the exact view. The force from the roof is the highest one compared to the ground floor, compared to the first floor. Okay, while this is the YZ view for the deflected shape, bending moment, and also the shear we get. And this is the bending moment, for the frame in the for this ECV analysis. So beside that, we also can get the reaction of the frame. So I have put here the 3D view and also the YZ view also. Okay, that's all.
Okay, for the methodology, the 2D analysis and 3D analysis is important to this course because it is to get the information, especially in the multiple part of the design, and it's important to find the shear force and the movement happen each of the member and the reaction at the spot. There are certain difference between 2D and 3D, which is 2D can only has the axis of X and the Y, while the 3D can has the axis of X, Y, and Z. Next, the 2D can only find the information from the front plan and the side plan. Meanwhile, the 3D analysis can discover information at any side of the structure in three-dimensional. Then the data from the 2D analysis is accurate compared to 3D. And the data from the 3D is more accurate compared to 2D. This is due to the 2D only can involve the certain part of the structure, meanwhile the 3D analysis can involve any member in the structure. The information in 3D is wide and more precise compared to 2D analysis, make it better than 2D. Okay, there are certain reasons why the manual calculation and the software calculation has the difference in value. This is because this is because there are certain reasons why the information from the manual process is different from the software Windows and SAP 2000. Because as we know, the software information is more accurate compared to the manual one. This is due to the statistical error when calculating. Okay, this statistical error is happen when the calculator gives the different answer, but it is nearest to the value. Even though the value is nearest, but it can have the huge change when the value is changing from the power of multiply and others. And the other reason is there's maybe some error when doing the moment distribution method. As we know that when we do the moment distribution method, there are certain value need to be changed, and there are certain value need to be changed, like the negative and the positive integer, and maybe due to the error when distribute the data.
We conclude that to our client, we could say that if they want to, they could choose whether to use Eurocode or British Standard because it both have its pros and cons. And we could say that if they want to save more money and time, they could use Eurocode too. And if they want to be a little bit or little bit more, they want to like provide more cost, they could use British Standard. And here also we could say that the uses of softwares are very convenient, and it's much easier and save our time. So that's all from us. Thank you.